Hey guys, this is Brian from Make Room at Eline Media. You've probably heard the term game engine before, but may not know exactly what it means. It can be helpful to think about a game engine like you might think about the engine in a car. An automobile engine powers the car, letting the driver take the car to many different places and accomplish many different tasks. Normally, a car's engine just works behind the scenes, allowing the driver to focus on where he's going rather than having to worry about the mechanical details of making the car run moment to moment. Game engines do a similar thing in video games, and particularly in the development of video games. Game engines work behind the scenes to power the play and making of games, allowing game makers to focus on creating the game experience they want without having to focus on every technical detail moment to moment. On large commercial game projects, game teams may invest lots of time and money over many years, even decades, to create and extend their own game engines that meet the needs of their projects. Recently, it has become easier and easier for new game makers, small studios, and even individuals to gain access to game engines that allow them to easily make the kinds of games they want without having to develop their own engines from scratch. Most game engines contain a few common subsystems that work together to provide the capabilities that most modern games need. Games need a way to capture the input provided by the player and share it with other game systems, which then use it to affect what is going on in the game. Where the inputs come from and what they are will differ depending on the gaming platform, but every game needs a system to process this input, otherwise the player wouldn't be able to interact with the game at all. Many games involve some sort of simulation of the physical world and the way things move and interact in it. How cars move along a racetrack, how a torpedo flies through space, how high an avatar jumps, and so on. Modern games use the mathematical formulas of physics to accurately simulate how objects move in the physical world in real time. We call the systems that do this in games physics engines. Video games often contain characters other than the player, for example, enemies and friendly non-player characters, or NPCs. These characters move and interact with their environment on their own without any input from the player. Like all things involving computers, the behavior of these characters is based on instructions that are represented in software code. Sometimes the rules are very simple, sometimes they are extremely complex. So complex that it can appear like the character has a mind of its own. We refer to game systems that control this behavior as artificial intelligence, or AI. Game engines need to know things like the location and condition of everything in the game world. We call this set of information the game's state, and so game engines have a system called the Game State Manager that tracks and updates this state information and makes it available to all the other game systems. Finally, modern video games contain subsystems for creating the visual and sound output needed to present the game world to the player. These graphics and sound engines take all the information about the game state and use it to render the moving images and audio we experience as players. Game engines may include other systems that are specific to the kind of game they're powering, for example, the inventory system in an RPG. But almost every game engine will contain these key systems, which work together to let developers create amazing games more easily.